Hello everyone, welcome to this module. This module is going to be the final module and will encompass everything that we've learned so far during this course. Now in this particular module, we're going to be taking a look at exploiting Metasploitable 3. Our goal is to achieve or to get system privileges or administrator privileges on the target and to obviously crack as many passwords as we can. So we're going to start off first of all by of course taking a look at the Nmap scan that we had performed early on. So I'll just open up the Nmap scan here, and we can get started by analyzing some of the services that we're running. Now we analyzed during the first two modules when we were taking a look at scanning the target. We were able to deduce that the system is vulnerable to the Eternal Blue exploit, which we'll take a look at in a second. And if we take a look at some of the other options here or the other services that are running, we can see that on port 8020, we have a service running on port 8020. We also have a service running on port 8383, which were very interesting. So if we open that up, so 10.10, so port 8383, we can see that we have Manage Engine Desktop Central version 9. If we perform a quick Google search here, so that is not google.com, so google.com, and we search for Manage Engine 9 exploit, right? We're looking for a Desktop Central exploit, and let's see if we can find any potential exploits. So we have a Rapid7 link here that looks like this will probably be a Metasploit module. We can just take a look at it in a second here. So this is indeed a Metasploit module. Let's take a look at some of the other exploits that are currently available. And we can look for the Rapid7 exploit. So we can say Rapid7. So we can say site Rapid7. Rapid7, hit enter. Rapid7.com, I believe. There we are. So let's take a look at some of the exploits that are currently available and we can try them out. So we can actually open up Metasploit. So I'll do that right now. We'll open up a new tab here and I'll just enlarge that. So MSF console, there we go. That should start up the Metasploit service or the Metasploit console. And we're going to search for Manage Desktop or Manage Engine, right? That's the name of the service. And yeah, we're just going to search for that. So again, just waiting for the Metasploit console to begin or to start. So Manage Engine, and we'll get rid of the spelling mistake here. All right, so it looks like we have a few exploits here. We're looking for version 9. So I'm just going to try and reduce the font size here so that we can see everything. And I'll just perform that search again. So pretty much the one that pops up the most, if we take a look at the exploit links here, is we have a connection ID vulnerability. Let's see. What other exploits do we have? This is the main link, I believe, that will take us to. This gives us remote code execution. I'm not sure about the version, nothing much there. So if we take a look at some of the exploits, we can see under exploits, we have auth upload, that Manage Engine, multiple products, authenticated file upload. That's really not what we're looking for. If we take a look at the bottom here, we have the App Manager exploit. And then of course we have connection ID write, which is again targeting Manage Engine Desktop Central 9. Right, so this one looks like a potential candidate for a vulnerability or the exploit. So we say use, and we'll say use this module, and it's going to set the default the default payload to Windows Meterpreter Reverse TCP, which I guess is fine. So we can say show options, and the port is going to be 8383. So we'll set the rhosts. In this case, the Metasploitable 3 IP address is 10.0.0.6. and set the R port. We're going to set that to 8383. And we also have SSL enabled. So we'll set SSL to true. So set SSL to true, hit enter, right? And the L host and L port options look fine. So that's the current Kali IP, and L port can be 4444. So we just hit run. And let's see if we can get an actual session here. So it's going to create a JSP stager. and it's going to upload this stager, execute the stager, and we get a Meterpreter session right over here. So it's also going to delete the JSP stager that it actually created. So we can open up the Meterpreter session now. So if we try and enumerate some information about the system, we can see the computer name is Vagrant 2008 R2. The architecture is 64-bit, but we have a 32-bit Meterpreter session, which we want to change. If we say get use ID, we can see that we have NT authority, but we're currently the local service. What we want is this system or the system privileges, so NT authority system. So we pretty much cannot do anything much because we do not have the appropriate permissions. It obviously changes when you're dealing with Windows Server as opposed to Windows, the desktop versions of Windows. We'll probably need to try some privilege escalation. But again, we also have the Eternal Blue exploit that we can try. But if we try and monitor the processes, we can try and migrate. So let's see what process we can actually migrate to. You can see most of the services are the 32-bit processes. So we can actually look for the explorer.exe, which is usually a very stable way of migrating into a 64-bit session. And we can just use pgrep. So we can say pgrep explorer, like so, and we can see it's 4708. That is the process ID, so 4708, and we can try and migrate into that. So we can say migrate 4708. I doubt we'll have the relative permissions. There we are. We can see we don't have the appropriate permissions, but we can look for a 64-bit session and try and migrate into it. I'll try and migrate into connectionhost.exe. So that is 3560. So we can say migrate 3560. 3560, hit enter. And let's see if we can get a 64-bit Meterpreter session. There we are. So we can say sysinfo, and we can see that we have a 64-bit Meterpreter session now. So given that we have this now, we said get use ID, we still have the local service permissions. We now need to try and escalate our privileges into a NT authority. So let's see if we can use the exploit suggester. So we'll put this in the background, and we can search for the suggester. So search for the suggester, and we can then say use the suggester. And if we take a look at our sessions, we have session 1. So we will just say show options here. And we set the session to 1, and I'm gonna hit run, and we're gonna let this run. So it looks like we only have a few exploits that we can use. So what we can try and use, and one that looks the most likely, is MS10092. We can perform some research on this, and let's see what this brings up. So we can search for MS10092. We can click on that here. And we can take a look at what this exploit pertains to. So this is an exploit of vulnerability within the Windows Task Scheduler, which is fine. The security update is rated important for all versions of Windows Vista, Windows Server 2008, Windows 7, and Windows Server 2008 R2. All right, so it looks like this will actually work on Windows Server 2008 R2. So we can actually just say use and paste that in there. And we can then say show options, and the default payload is set to Windows Meterpreter Reverse TCP. We can set that to a 64-bit session now. So Windows, we can say Windows x64 Meterpreter, and we can then say reverse TCP, right? And we hit show options again. And we can then set the L port, because we want to keep it different from the session we already have running. So we'll set the L port to 1234, right? And we can then hit session. So session 1, set the session to session 1 and hit run. And let's see if we can actually get or escalate our privileges. So it looks like we were able to escalate our privileges, and the scheduled task was successfully deleted. Let's take a look at what actually happened. So error, the specified task. It doesn't look like this particular exploit worked. So that doesn't look like it actually works. So if we list our sessions, we only have one session. So if I say session 1, get use ID, we're still local service, so we can try and display these services, and let's see if we have any new services here, and we still do not have any relevant permissions, so we are pretty much going to have to try the Eternal Blue exploit. So in this video we essentially took a look at gaining our initial foothold, and in the next video we'll take a look at how to exploit the Eternal Blue vulnerability, and then of course we'll be taking a look at how to dump the password hashes and then how to crack them with John the Ripper so that we have a total control and access to the system. Alright, in this video we're going to be taking a look at how to exploit the Eternal Blue vulnerability. So what I'm going to do is, if I list out my sessions, and I'll just put this one in the background so we can have it running, we can search for Eternal Blue, so Eternal Blue, and we can try out the first one right over here, which is exploit Windows SMB MS 17010 Eternal Blue. And this essentially, this is the SMB remote Windows kernel pool corruption. So we can try that. And if that doesn't work, we can also try the SMB or, the MS 17010 PSExec, and that'll allow us to also get remote code execution. So I'll say use, and we will say show options, and by default it'll select the 64-bit version of Meterpreter. So you can see that this works on Windows 7 and Server 2008 R2, all service packs. We'll set the L port to 1234 and set our hosts to our hosts will be 10.0.0.6. that is the Metasploitable 3 IP, and we'll just hit run. And let's see if that works. So it's going to send the payload. So the target architecture selected is valid. Trying the exploit, and it's going to send all but the last fragment of the exploit packet. So it looks like we were able to get a second Meterpreter session. And there we are. That looks like it works. So again, sysinfo. You can now see we're still on the Metasploitable 3 VM, and we have a 64-bit session. If we say get use ID, and now we have NT authority and system privileges. So we can take a look at the processes, and again, we now have the ability to view all the processes. What we can do now is we can try and actually dump our hashes, and we can do that really easily by first of all, we can actually use the hash dump module. So we can put this in the background, and this is session 2. So we can search for hash dump, and you can see that we're looking for post Windows gather credentials and domain hash dump. That's the Windows domain controller, of course, and then we can also use post Windows hash dump. So this is for the Windows local user accounts. So we can also use that. So we can copy that and say use, paste that in there, show the options, right? And we set the session to session 2. So we can say set session 2, hit enter, and we can hit run. And it's going to say obtaining the boot key, calculating the hboot key using sys key, and obtaining the user list and keys. Let's see if we can actually enumerate the passwords. So I'm just going to wait for this to complete, obtaining the user list and the keys. So hopefully this works. Otherwise, we can just use the default hash dump. Of course, we also have the ability, and we can see that it did work. We also have the ability to use the Windows Smart Hash Dump module as well. So these are the hashes we get. What I'm going to do now is I'm just going to copy these hashes, and we are going to add them onto our desktop. So we will just go into my desktop, and we'll say vim hashes, and we'll say ms3.txt, and I'll just paste them in here. And these are the hashes that we'll be trying to crack with John the Ripper. An additional thing that we can do, or an additional step we can take, is to set up persistence. So what I can do is, if I take a look at my sessions, the ports that we have configured are 4444 and 1234. So what we can do is we can say, and we'll use the session that has the system privileges, which is session 2. So we will search for the persistence module, and we are looking for the Windows persistence module, which is right over here. So exploit Windows local persistence, and that uses the registry. So we'll say use, and we'll paste that in there. right? And we say show options. The default, it looks like the default payload is Windows. So we'll set the payload first. So we say set payload to Windows x64, and we say Meterpreter reverse TCP, right? And we say show options, and we set the L port to, we can set it to something else. So we can say 1245 or 1243, and we can then set the session to session 2. So we say session 2, hit enter, and we can then hit run. And it looks like we weren't able to set up persistence using this particular module. So what we can do is we can try and look for another persistent service. So we can try and use the exploit Windows local persistent service. And this essentially sets it up as a service. So we'll use this particular module. And again, we'll set the payload. So set payload to Windows x64. And we can set the Meterpreter reverse TCP, show options. We can set the L port 1243, and we can then set the session, set the session to 2, and hit run. And let's see whether we can set up. So it looks like it only supports the Windows Meterpreter shell reverse staged payload. So we can set the payload to Windows Meterpreter reverse TCP and hit run, and let's see if that works. And indeed it works. So we've set up the persistent session, and we can see we have a third Meterpreter session. So we have essentially we have elevated our privileges, we've set up persistence, and we've dumped the relevant hashes. The next video will be taking a look at how to crack the passwords that we've or the hashes that we've actually gathered with John the Ripper. So I'll be seeing you in the next video. Hello everyone. In this final video, we're going to be taking a look at how to crack the various Windows hashes that we gathered from the Metasploitable 3 virtual machine. Now, as we did in the previous video, we were able to save them into a file called hashes ms3.txt. And given that we've already taken a look at how to crack the Windows NTLM hashes with John the Ripper, again, it's very, very simple to do. So we say sudo John, and we set the format to nt, and we can then say word list is going to be equal to user share word lists, and we're going to say rocku.txt, and we will then specify the file. So hashes ms3.txt and hit enter. It's going to ask me for my root privileges, so we'll just specify them right now. Just enter my password, and we hit enter, and the cracking process begins. And it looks like we have a some accounts that have been cracked. In this case, we can see the administrator account password is Vagrant, and the account C3PO has a password of protocol. We can try and use the fork option. So we can say specify the fork option because of the there is no OpenMP support. So we say fork is equal to 4 and hit enter, and let's see whether we can crack anything more here. So nothing more. What we can do is we can try and change our word list to something else, but in this case we've got the administrator password, which pretty much means that we have total access to the system. And of course, out of the users that we were able to see, so for example, if we say cat hashes ms3, there are plenty of other users on the system, and we can probably crack them using the default John the Ripper word list. So if I can get rid of the custom word list, which in this case is rocku, we can get rid of that, and it'll then use the default John the Ripper word list. So again, this is going to now take computational power, and of course we can actually monitor this. If I go into a new terminal and hit htop, you can see my resource consumption is now 100%, because now John is using all my CPU power to crack these passwords. So again, this is using the default password list that was under the John etc user share John directory. So again, this will take, depending on the complexity of the password, anywhere from a couple of minutes to a couple of hours. And of course, it's also going to depend on the on the amount of user accounts and passwords that currently exist. That being said, we've been able to get the administrator password, and we can actually test this out. So if we just try and open up or bring up the Windows Server here, we can say log off, and we can then try and log in. So we can say input, keyboard, control, alt, delete, and administrator, and the password is Vagrant, and we should be able to have access to the administrator account. There we are, and we now have access to the administrator account. So that was how to exploit the Metasploitable 3 virtual machine. It's a relatively simple virtual machine to exploit, but again, it is intentionally vulnerable for that same reason. It's there to teach you the various techniques, especially the various exploitation techniques and post-exploitation techniques that you can perform on Windows systems using Metasploit and the Metasploit console. So thank you very much for joining me in this course. I hope you learned a lot. I would love to have you back for more courses, and I will be seeing you in the next course.
Hello everyone, welcome back. Since this entire course is dedicated to session hijacking, let's try to understand what is a session. Also, we'll try to understand how are sessions being implemented on both web and network. We'll just go through the basics for now, and in the next module, we'll take a deep dive on various implementation mechanisms. So what is called as a session? Session is nothing but the connectivity that is being established between a client and a server. All the devices over the network has to set up a communication in which each of those is going to send a request and the server is going to respond back with an appropriate response. So each session is going to be identified with a unique value known as session ID. So these session IDs are generally a numeric or alphanumeric value based on the implementation from the development side. So each session ID will be uniquely mapped with the user in order to identify who is sending the request. Now, let's take a look at the web-based implementation. So over the web, the default protocol that would be used is HTTP. So HTTP protocol is by default stateless. So what does that mean? So ideally, the web server cannot store the information to uniquely identify the client, since each of these requests is being understood on isolation or one-to-one basis. So now let's try to understand this scenario. So over the internet, let's assume a case where there's an abc.com web server. So once a user A is trying to send a request, he will send out his own session ID once he's been authenticated, or with authentication as well. This is done in order for the web server to uniquely identify each user, since over a period of time, we may have multiple users sending out multiple requests. So in this particular scenario, we can see that both the users A and user B have a unique session ID. So this is how a server is going to respond back to each user based on the request that they send it out. Along with those, HTTP protocol also sends out multiple headers. So in this scenario, we can see the type of request. The user agent is nothing but the browser that is being used to send out the request. What is the domain name, and what are the data types, or what are the separate encoding mechanisms. Now similarly, let's try to take an overview about the network protocol. So in this particular scenario, let's try to understand how TCP works. So unlike HTTP, TCP is a connection-oriented protocol, also known as stateful connection. So that means it is going to maintain the information about the session till the time it is active. TCP protocol is also known as three-way handshake protocol, which is also known as SYN, SYN-ACK, and ACK. In the first step, the client is going to send out a SYN packet, informing the server to initiate a session. In the response, the particular server is going to take the SYN packet from the client, increment it with a value of 1, and send an acknowledgement packet with another random value. So in that way, the client, once it receives it, once it calculates the increment of value of 1 for the SYN, it does understand the server has received the request, and it has also sent out an acknowledgement packet. So in the final step, the client is going to send back the acknowledged packet, increment it with the value of 1 and send it back to the server. So in that way, both the client and server both know that both have accepted the request and have sent the response and the connection has been established. So in this particular section, we have looked at both stateless session in which the requests are processed in isolation and the stateful session in terms of TCP where each and every request is being tracked and maintained until the session is active. That is for this video. Thank you. Welcome back. As we'll see throughout this particular training that we talk all about session hijacking, different prevention techniques and attack scenarios. In this particular slide, I just want to touch base generically as to what we mean by the term session hijacking. So let's take a scenario where a user is trying to communicate with the server and sending out requests. And in response, the server is also going to respond with the appropriate HTTP response code. So when we talk about session hijacking, we are talking about a scenario where we have an attacker who is trying to get into the communication because he really wants to do is take over the victim's session itself with a machine that maybe simply he may want to impersonate them, or it may also mean that they want to boot the victim out of the connection altogether. Now, this all depends on the style of the attack the attacker is trying to perform over here. It could also be the scenario where he would want the victim to think that he's still logged in and they still have a good connection. Or it could also be scenarios based on the application itself that he may have to log the user off and take over the session. Now, we will cover all these scenarios when we go in depth about various attack scenarios and the criteria for each of those payloads to be executed. So as we have spoken about a few times now, there are different types of session hijacking. So let's go and take a look at those as to what are the different types in the next particular slide. Just to give a brush up again, so the attack techniques that the attacker may use maybe want to impersonate the victim, just have a simultaneous access, or you may want to log the user out and continue the session. But in either ways, this attacker is trying to impersonate the victim. So in this particular section, we looked at what is termed as session hijacking, in which the attacker overtakes the victim session and impersonates their activities. That's it for this video. Thank you. Hello everyone, welcome back. As I cover the different types of session hijacking and the in-depth hands-on over Module 2 and Module 3, let's take an overview about the types. So predominantly, all the attacks are going to be broken into two main categories. The first category is application level hijacking. So when we talk about application hijacking, we are going to talk about the web application which runs over HTTP and serves up an HTML document. There are multiple ways and classes of session hijacking that can be performed against the web. Similarly, the second type would be the network level. In this particular scenario, we are talking more about different types of protocol such as DNS, TCP, UDP, and so on. Just to give an overview of the different type of attacks over the web and network. So the first one would be man the middle, which is nothing but the scenario where the user is trying to sniff out the user session over HTTP. Session fixation. So session fixation is where the attacker actually provides a session ID to the user and then they pull out the user data back. Similarly, we will be looking at something similar known as session ID brute force, in which we are trying to actually manipulate and generate a session ID which would be validated by the server, and in response it will grant us the permission to take over the session. One of such attack vectors would be cross-site scripting, in which we'll be taking a look at how do we inject JavaScripts, that is malicious JavaScripts, which would in turn execute set scripting vectors, and how do we hijack user sessions. Session donation is a scenario where the attacker forges a profile and gives over the entire session to the user, just expecting them that they enter some sort of data, and the attacker can then obtain the session ID itself. So the next attack vector could be man in the browser. So in which we are talking about malwares that are injected, and this is just one such attack scenario that can be performed by man in the browser, and we try to hijack the user session. Now, just taking some sort of scenarios over the network could be sniffing again, in which we use tools such as Wireshark. The expectation is such that the attacker is also sitting over the same network and is trying to sniff out the network packets and identifying the session IDs. So predicting the sequence is also such scenario in which we are trying to perform session fixation itself, in which we are going to enumerate and expect the application accept the particular scenario. We'll also be taking a look at protocols such as UDP and how and what tools can be used in order to perform session hijacking. IP spoofing is one such vector in which an attacker is trying to spoof an IP. Maybe that's how the application or the network is being configured in order to accept or authenticates a user based on a specific IP. So we will see such tools in which we can use and impersonate another user's IP. One such protocol in which we'll be taking a look at is Telnet. So we'll see the type of tools that can be used in order specifically to hijack Telnet sessions. And we'll also be taking a look at DNS sessions as well, as to how does a DNS protocol work and what are the tools that are capable enough in order to hijack a DNS session. Similar to IP spoofing, we'll also take a look at the R spoofing, in which we'll try to figure out the tools that are capable enough to simulate a physical hardware and generate custom hardware addresses, and that can be used in order to perform ARP poisoning. And lastly, we'll also take a look at an SSL strip attack, in which how an attacker forging a network can actually strip out an SSL connection and just expecting the victim that is already on an SSL secure connection, but in reality, he is able to sniff out the actual traffic in plain text. We'll also take a look at the different tools that would be used over our hands-on sessions. That's it for this video. Thank you. Hello everyone, welcome back. In this particular slide, we'll be taking a look at the list of tools that we'll be using for our hands-on. So to start with, you would need a VirtualBox or any other software such that can run different virtual machines on top of it. So I have used VMware Pro, and I'll be running Ubuntu and Kali Linux as multiple scenarios. Next would be XAMPP. This is something I prefer because all the demos are on PHP. So XAMPP supports your PHP MySQL integration. Another tool that we'll be using is Burp Suite. So this is one of the HTTP proxy tools that we'll be using. This is used in order to tamper and to figure out the request and response that happens between the browser and the server. And for network level, we'll be starting with Wireshark, that is used as more of a network sniffer in order to capture all the packets flowing through an interface. Petrocap is also an advanced version of it. And ARPSpoof is something that we'll be using in order to change our MAC addresses. And Hijack is a tool that we'll be using in order to hijack Telnet sessions. Please refer to the download links available in order to install and read the manuals as necessary. That's it for this video. Thank you.
Did you know that you can be part of the lucrative cybersecurity industry? Even top companies like Google, Microsoft, Amazon, IBM, Facebook, and Dell all hire cybersecurity professionals. The cybersecurity industry has a 0% unemployment rate. The average salary for an entry-level cybersecurity job is about $100,000 per year in the United States. Furthermore, you don't need to know coding and learn from your home, and you get a scholarship to kickstart your career. Apply now. EC Council is pledging a $3.5 million CCT scholarship for cybersecurity career starters. Scan the QR code on the screen to apply for the scholarship. Fill out the form.
Hello everyone, welcome back. In this particular section 2, we'll be taking a look at HTTP protocol itself and how are the different ways we can implement sessions. And we'll also take a deep dive how does different network protocols also work. So now let's take a look at HTTP itself. So we have all heard about HTTP protocol. So technically this protocol is used when we wanted to access any HTML documents which are residing on a web server. On a day-to-day basis, all of the end users, they use a browser in order to access a website. So when we talk about a website, it contains many documents or resources, as we call it. So that could be your HTML document itself, that's a content, followed by CSS files that are very useful in order to decide the layout. JS files could be used for animations or validations, and images and videos depending on the type of site we are visiting. So when a browser makes an HTTP protocol request, it is trying to fetch all of those required resources so that the end user can view it. So the browser will actually try to construct the document and decide the layout based on the coding on the backend. So this is how a typical HTTP works. In the last section, we did take a look and understand as to why is HTTP known as stateless. That means HTTP cannot manage which request is sent by whom and so on. Since it's a stateless protocol, it will actually work in isolation. So in order for a web server to actually analyze which user is sending what type of request and what is the exact type of content that has to be sent back, we would try to maintain a session that is called a session persistence. So typically there are multiple ways, how session can be persisted. And it is known in different formats such as session ID, session token, and a cookie. In technology and implementation, they are a bit unique and different, but for simplicity, let's say that all three work in the same fashion. So we did take a look at the similar scenario in the previous section where a user is trying to send a request. The request could be browsing a web page, trying to send a login credential, or any other activity. And the server will respond back. So it will also respond back with a unique token. So this unique token is different for each user. And that is how it will try to identify which user is seeking which request and what sort of response has to be sent back. So how does the server actually take a look at the request token itself? Because once the server responds back with the initial token, then for each and every request, the particular token would be embedded and sent back to the server. That is how the server is going to understand how user A is different from user B and what are the different responses that it has to send back to each of the user. So we are trying to talk in terms of technology agnostic. So that means we are just trying to understand how or the different types of mechanisms how session can be persisted from the server point of view. In most of the cases, the data is stored in memory. So that means the particular session is based on the service that is running on the web server. So in case if the service is restarted, that means the session tokens will be purged and it has to be sent back or the user has to log in back again. One other mechanism is that all the session tokens are actually stored in a database. This could be one other implementation where all the session IDs are stored, and that is how the server is going to uniquely identify each of these requests. Now, quickly, let's take a simple example. So I've just opened up the developer tool using F12. And this is a simple local application that is running on my local machine. So what I'm trying to do is that just going to log in using my credentials. So what has really happened now? So we can actually see that a unique token has been sent back. So this particular value is going to be assigned to the user Tom. So let's try to browse the same URL again in a new tab. So we can still see that even though we opened up normal page, initially we did see a login screen, but right now it again welcome back the user Tom. This is just because of the reason, because the session is being persisted on the browser itself. Now, if I just delete the session itself or the cookie or in memories cookie, and I'm just trying to refresh the page. So we can see that since the session was actually eliminated, so the user was logged out. This is one of the simple example how a session is being persisted on the web server. So the key important points that we learned is that every request is actually stored so that the session can be persisted in order to identify different user and the request. And there are different types of session management. We want to call it in terms of cookies, session tokens, or session IDs. That's it for this video. In the next video, we'll be trying in depth to understand what are the different types session can be implemented and persisted. Thank you. Hello everyone, welcome back. In this particular slide, we'll be taking a look at the different types of HTTP session persistence. As we previously looked at HTTP protocol being stateless, we need to find mechanisms in order to persist sessions so that each user can be uniquely identified and the response can be sent from the server. So in this module, we will not be taking a look at the development per se, but just to identify the common mechanisms and to understand how we can leverage those mechanisms and attack those scenarios. So the common types of session implementation that we see are via cookies, followed by session ID passed by the URL, and last being the hidden forms. So let's take a look at the first case scenario, cookies. So what are cookies? The cookies are a small file which is actually being downloaded to your computer via the browser. This is something that is used by the server to recognize the user so that they can access different services and resources. Now let's look at a small demo. So as you can see, this is a small code snippet that I've written for PHP cookie-based session management. So let's try to dig deep into the developer tools. So just press F12. So just for the demo purpose, I'll clear out all the existing cookies. And now let's try to refresh the page. As we can see, a cookie has not been set on the first request and it was generated. So what does that mean? So a particular file has been downloaded to your computer with the cookie having the name user with the value of the username itself, and that has an expiry date for a given time. In this particular scenario, it is for a day. Now let's try to access the request again. As you can see, on subsequent request, the cookie was sent to the server, and for each request, it was able to identify who the user is actually trying to request. So one of the common advantages of this scenario is that even if the user actually closes the browser itself, since the cookie is stored on the computer, the server can actually recognize for each request. Let's try to figure that out. I'm just trying to open up a new window and setting out the request again. In this scenario, we can see on the first request itself, the server was able to identify whom the user was. Unlike the previous scenario where I cleared out the cookie, and on the first request, it was not able to validate the cookie itself. Let's try to look at the advantages for this. This is something can be used for each request and to persist the session for a longer duration, since the cookie can always have a long expiry time. And second use case would be what we saw in the demo, that if the user, even though he closes out the browser, he can always log in back, since as long as the session is valid or the cookie is alive based on the expiry time, the session will be reactivated. There are some drawbacks to that also. The first drawback would be the user can always maintain only one user session. In case there are applications where user has multiple accounts, since the cookie will actually be tracked back and you can always log in using only one browser. There are alternate ways to do so, maybe using different browsers or actually using incognito mode can be used. Second drawback is that if the cookies are not actually secured in terms of the properties, then there are additional web attacks such as cross-site scripting that can be used to leverage and steal those cookies, which is something we'll be taking a look at the hands-on section. Now, let's look at the second scenario where the cookie or the session ID itself is being passed over the URL. So this is again one such demo in which it's a small code snippet which shows that on each request, a unique PHP session ID is being sent to the server and which is something that will be used. So these are the scenarios where the browser or the end user's client might not support cookies. These are very useful on those scenarios. So the way we can see for each request, a new session ID would be generated and the same value would be used for the particular user login session. So the major advantage would be that multiple or parallel sessions can be used, since for each request, a new session ID would be generated. And these are mostly used in the cases where cookies are not being supported. Similarly, there are drawbacks to this as well. The first drawback would be that if the session is being closed or the browser is closed, the user cannot log in since it was maintained for that particular tab, the window. And second drawback is that since the session ID itself is being passed over the URL, so all the web request is being logged over the access logs, or there might be additional network devices that actually cache each and every request and store them. In that way, it is an information disclosure where an active session might be disclosed to any user or any attacker. Now let's take a look at the last case scenario where a hidden form is being used. So this is another such code snippet in which we are using a hidden form. Now let's try to inspect the form itself. Just for demo purposes, I've actually pre-filled the form values. If I use a developer tab and actually I try to inspect the form, I do see now there are different text fields as shown in the demo, and that's an additional hidden field which is actually generating a PHP session value. So now let's take a look what happens if we submit the form. You do see that the form was submitted with a 200 response. So if we just click on the file itself, we can see what has been submitted. So we have been successfully been able to submit all the values along with the hidden field which is actually maintaining this session. This particular scenario is quite similar to what we saw in a previous scene where the session ID was being passed over the URL. It can be used for same multiple parallel sessions where each and every request has to be sent over the form itself. And since it is generated over the form itself, there's no need for cookie. So wherever an end user is using an unsupported browser, this is something can be used in order to maintain session persistence. We do have a similar drawback as to the last scenario, where if the particular browser is being closed, the session would be terminated and the user again would need to re-authenticate and open up a new session. And one of the drawback is that each and every request has to be sent via post method only. So what does that mean? We cannot have any hyperlinks. At the same time, we cannot secure any of those resources such as images or videos because everything has to be sent via post body. And one other thing to notice is that this particular method would be very hardly seen in today's modern web development. This is something that was being used way back when the WWW actually started, where the web development was made. Just to have a summary of this section, cookies actually used in order to maintain persistence over a long time. In case if those are not secured properly, there are certain attacks that can be used in order to steal those cookies itself. And other mechanisms such as passing the session over the URL or over an hidden form is something can be used whenever a browser or the client will not support use of cookies. But these are actually susceptible to common attacks. That is for this video. Thank you. Hello everyone, welcome back. In this particular section, we'll take a deep dive into the network protocols such as TCP and UDP and few more. So in part 1, we'll be taking a look at TCP first, followed by the UDP. So as we have looked at in our previous module as to how does a TCP session is being maintained. So TCP is a connection-oriented protocol. That means it will create the history as to what the request was and ensure that packets are being delivered in a timely fashion. So just to reiterate, the TCP handshake is a three-way handshake in which the first step, the client will send out SYN packet which will have a random value X just to initiate the connection. Followed by, to acknowledge that particular request, the server will send back SYN and ACK, in which the ACK would be incremented by the value 1 and SYN will have another pseudo random number. And in order to finally confirm the connection, the client will again acknowledge an acknowledgement packet with an increment value of y plus 1. So now let's try to figure out how can we actually analyze using the tools. As you can see, I have a tool called Wireshark that I will be using in order to analyze the TCP packets. So Wireshark is nothing but a packet capture tool which can be used over the network to capture raw traffic, and this particular tool will actually segregate each of those requests and give us more additional information. This is something very similar to a proxy tool that we can use for web browsers as well, which will actually sniff out the web traffic, such as Burp Suite or Fiddler. Now, let's try to focus on the first three requests over here. So what I've tried over here is that I've actually looked at an entire TCP stream connection. So this is the first particular packet that I have on my packet capture. So as we can see, we have all the three particular handshake in place. That is the SYN packet, followed by the SYN and ACK, and the last again being an ACK packet. That is a three-way handshake. This is the particular header sequence that we can see over here that has the source port and the destination port of this communication between two particular IPs. So if we look at the first sequence 0, that is something known as the relative sequence number. The reason particular tool is showing the relative sequence number is just for human readable form. In actual practice, we will have a huge pseudo random number that will be used over the network, which is something that makes it very difficult and interesting for the network in order to perform any session hijacking. So if we want to actually see the raw sequence number, so what we can do is that just go to Edit, Preferences, Protocols, and scroll all the way down to TCP. Once you go to TCP, we see a particular option that says relative sequence numbers. Just try to uncheck this box. Just let's click on OK. Now what we see is a pseudo random number. So that is how a particular value has been incremented to 1 if we see in this particular second request for SYN and ACK. So the logic remains the same, where a sequence packet will have a pseudo random number in order to make the session ID quite unique, and the acknowledged packet would be incremented by 1. And similarly, on the last packet, we can see an ACK packet would be incremented by 1. So this is something we can actually use to analyze, and for each of those TCP streams, we can actually, if we want to understand how the communication is really happening, we can just click on a particular packet and just click on follow and the TCP stream. That is how you can actually see the raw packet in place. So based on the traffic, since this is something that is being encrypted over SSL and TLS, we see that we are not able to read the actual data. But for normal scenarios, there is a place where a non-secure protocol such as FTP or an HTTP protocol is being used. That is somewhere we can actually see the raw packets in place, and we can actually read what data is being transferred between both of those assets over the network. Moving forward, let's look at UDP protocol. So in contrast to TCP itself, this is a connectionless protocol and in which the data is sent over the connection automatically. Unlike TCP, there is no proper communication in which there will be no acknowledgement or anything. Once the client sends a request, the server will actually start bombarding with the response and just hoping with the fact that the data just reaches the client. This protocol is actually needed in terms as compared to TCP because there are many protocols that would need a faster data services such as DNS, TFTP, or for a day-to-day example, we can focus on video streaming. So these have to be real time in such a way that all the packets are sent back to the client as soon as possible. Now let's take a look at again over the Wireshark tool itself. How does one actually figure out a UDP packet? On the search bar, you can just type out UDP. So what does that do is that it will list out all the protocols that are working over UDP. So unlike TCP, we can see that a UDP packet is quite small, in which it has 8 bytes in the header and only 4 fields. That would be your source port, your destination port, and the length of the data itself. There's one other packet which will actually use to check the checksum. So checksum is just to calculate if all the data has been sent as it is or if they have been tampered. But if you see in this particular scenario, it shows that it is unverified. So again, let's go back to edit, preferences, protocols, scroll down all the way to UDP. So we do see an option which says validate the UDP checksum. So let's just click on it. So once we just clicked on it, we can see now it is able to actually calculate the checksum. This is something that will actually validate the data saying if someone has actually tampered it or not. Same time, if we want to figure out if which protocols are actually using UDP, we can just click on the UDP itself and just apply as column. So which will actually say if the particular protocol over the sniffed packet itself is actually using UDP or not. So just a summary to this section, TCP is always reliable and it will follow a three-way handshake. This is used in most of the cases where we need to ensure that connection is actually reliable, where the data is actually arriving on time and in sequence. And UDP is something that is being used for more of a fast data transmission. So that means that the application layer is the one which will have to take care of all the error control or the sequence of data, which is something that the protocol itself will not take. That is for this section. Thank you. Hello everyone, welcome back. Now let's take a look at the next set of network protocols. The first protocol that we'll be taking a look at is Telnet. So this particular protocol is used to connect against any open ports on the remote server. So this provides a bidirectional interactive session. So typically, Telnet can also be used in order to log into a Telnet server using the user credentials. So one of the reasons this protocol widely exists is because it is easily deployed and available on all major operating systems. So in such a way, a ready-made toolkit is available in order to connect to any open ports. One of the major drawback of this protocol is that data is sent in plain text. So this creates an attack vector for any attacker to sniff the data that is being transmitted. Let's take a simple example of how Telnet works. I have a Windows command prompt open as a victim, and we'll be trying to connect onto a Linux system running a Telnet server. For that, I'll just go ahead and start the sniffing. Now, in order to start the telnet connection, I'm going to type in the command telnet, followed by the port number and the IP address of the server. So as you see, I am prompted to a login session. So once I log in, I can perform the basic commands that a root can type in. So let's go ahead and sniff the traffic. So when I sort of typed in, we see that we have a connection established between the client and the server that was intercepted. I'm just going to go ahead and follow this stream. So as we can see, we have all the data in plain text that is being transmitted. So in this particular example, I have intentionally put in a weak password. So the username being root and password being Ashwin, which was in the plain text. So this sort of limitations on the protocol itself, where data is being sent in plain text, the attacker can sniff any sensitive information. Now let's take a look at the next protocol known as DNS. So DNS server stands for domain name server. So typically this protocol is used to map the IP address and the domain host names. So typically as an end user, we cannot remember all the IP addresses on which different applications run on. So rather than that, we use human readable form such as domain names such as www.facebook.com, which can be easily remembered by us, and we can use that in order to access the server. But ideally, this server is going to resolve the domain name with the IP address such that the connection can be established. So technically, this particular informations are stored in the host file that is available on different operating systems, which will have the basic mapping. In case the DNS information is not available in the host file, then we have got DNS servers that are configured on our router, so which again lead to the mapping. So technically, one of the drawbacks is that these DNS queries do not actually track from where the information is being requested. And one last protocol that I would like to talk about is known as IP address. So this is the actual IP address that we sort of use in order to access remote machines or the local machine. So that means every device over the network has to have an IP address either in the local network or over the internet in order to establish connection. Without this, none of the networking would be possible as of today. So one of the drawbacks of this protocol would be that it can be spoofed. So technically an attacker can actually masquerade his own IP address behaving as another known victim within the same infrastructure and carry any specific payloads. That's it for this video. Thank you.
Hello, welcome back to section 3. This section 3 is a hands-on module in which we'll be taking a look at the different use case scenarios and different payloads that attackers use in order to perform session hijacking. So let's get started with the first attack. This is known as cookie hijacking via cross-site scripting. So typically, in order to perform this attack, you would need a vulnerable website which is impacted by reflected cross-site scripting. Even though we will not deep dive into what is reflected cross-site scripting, we'll just take an overview. So typically in this sort of attack, what really happens is that the value that is being submitted to the website is actually passed as it is without sanitizing the input against any malicious content, and it will be added as part of the HTML document itself. Unless and until it is malicious, there may not be any major impact. But in case of the scenarios where the input is a malicious JavaScript, it will be appended to the HTML document itself and it will be executed. Now let's take a look at the hands-on. So this is a dummy website that I've created for demo purpose only. So in this particular scenario, we have a variable in the get parameter error that is actually vulnerable to reflected cross-site scripting. So let's take a look how does this work. So whatever values I would be able to pass on this parameter, it will be actually reflected. So as you see, whatever I've typed, it is passed as it is. Now let's think of something much more malicious. So now, as we can see, that actually we see a prompt, an alert that is generated because of the script that we have provided over here. So let's take a look at the source code also. So as we see, the malicious script has been appended to the content of the body. Due to this, while rendering the HTML document, it will actually parse step by step, and when it reaches the malicious JavaScript, it will also get executed. So let's quickly jump onto the developer tool also. So as we can see, we have a PHP session already been generated once we visited the website. So now let's perform some more payloads which can actually take out the cookie value. So instead of alert character 1, I'm just trying to use the JavaScript command document.cookie. So what it's going to do is that it is going to parse the document, that is the website, and the cookie that is being generated. So as we can see, the particular PHP value has been alerted. So as we can see, the impact because of another web-based attack, that is cross-site scripting, which attackers actually leverage in order to hijack sessions. So by hijacking, that means the attacker has to take this particular value and actually use it on his own browser. So how can we actually do that? So one of the common methodologies that the attackers use is social engineering. So what they would want to do is that create a malicious payload in which the moment the user tries to click on it, it will open up on his own browser. And as we saw in this particular case, it was able to fetch the cookie also. And taking that cookie, they will be downloading it on their own web server. So how can that be done? For demo purposes, I've already copy pasted the payload. So as you can see, an attacker can use any real-time attack such as tiny URLs. So these are URLs that are short in nature, but actually when they would be addressed by the browser, it will actually expand to a proper full-fledged URL. So if we send any of these short URLs to any of the victim, they will not even know what is behind this. And most of the time, it is quite right to assume from the attacker's point of view that they will click on it and they can actually take the cookie. So what I've done is that I've added additional commands to that. So what I've done is that in my own local system, for demo purposes, I have created an attacker page which is running on PHP. Under that, what I've done is that I've created a get parameter which will actually fetch the document value. And on the back end, I've also created a notepad which will actually save every session ID. So if I am able to send to multiple people and they run the same website and they click on it, all those cookies will be stored on my notepad. But in the actual scenario, it is pretty much sure that this document.location would be redirected to a different website that is owned by the attacker themselves, where they will be actually storing all those sessions in real time. And apart from that, there is one other payload that I've put. The moment this particular website redirects to this location for the attacker page, also created an additional redirect. For example, in this scenario, it will go back to facebook.com. So let's see what happens if a person clicks on the link. So this is the particular notepad that I have created in which will actually store all of those cookies in real time. As we can see, it has already stored this particular PHP value. So in this way, an attacker can actually store all the cookies in real time and use this on the website just by copying this value and actually going to the developer tool and replacing the cookie value. In that way, he will be able to hijack the session. Now, just to be sure, let's reiterate the scenario again. We have a user who's actually trying to access a website, and we also have an attacker in picture. So initially, the attacker is trying to send a payload using social engineering methodology, maybe via Twitter or any other messenger in case. So once the user clicks on the link, the request will redirect the web server, and the payload is executed and the response is sent back. And due to that, what is going to happen? The attached payload is going to send back the cookie, the hijack fashion to the attacker. That's it for this video. Thank you. Hello, welcome back to the second video. Now let's take a look at the second attack, which is known as session fixation attack. So in this particular attack, what we were trying to do as an attacker is that we have a pre-owned session ID. And that is something we want to fix on the victim side. So now let's try to look at the actual demo and try to understand how is it performed. As you can see, I have got two different browsers opened. On the left hand side is a Chrome browser, which is an attacker machine, and on the right hand side is a Firefox browser, which is on the victim. So how does this attack actually work? So the moment I actually visit this website, I have a session ID for myself. So if you look at the value, it starts with 2 and ends with B. So as we looked at the previous attack scenario where using social engineering, the attacker was able to hijack session. So similarly, in this scenario as well, the attacker is going to use social medium in order to send this particular token to the user. Ideally, the common applications that are more vulnerable to the scenario would be which would have the session ID in the URL get parameter itself. But however, this particular application is also vulnerable to reflector cross-site scripting. So we can perform the similar attack, and instead of hijacking the value, we can change the value as well. So leaving apart the social engineering tactics as to how the value is being sent out, now let's assume the fact that the value has been provided to the victim. So I'm just using an extension called Cookie Editor for simplicity. So we do see that the victim has got a different session. So as we spoke, the attacker is going to provide its own value to the victim. So now this is being stored on the browser. So when the victim will actually log in using his credentials, we see that he was able to log into the administrator panel, and the cookie value is the one that the attacker had given to him. So now the attacker in normal scenario just has to wait for the victim to log in. So now even without knowing the credentials or what is it, the attacker, since he has given his own fixed session ID, which he wanted the victim to use, that's already been set up and up and running and logged in. The attacker would just go back and just refresh the page. So now we see that just by refreshing the page, since the cookie was the same and it was not revalidated, so we can see how session fixation attack work. So just to reiterate the scenario, the attacker will have a legitimate connection initially when he is trying to fetch the session ID which he wants the victim to use. From that case, it's a social engineering tactics which you will be using it either via phishing or any such methodology to ensure that particular session ID is updated on the victim side. There's one other attack which you saw in the last video, that is cross-site scripting. When that attack can be used to ensure that the cookie value is updated. And after that, it is just a wait and watch game where the attacker waits for the victim to log in, and using the same value, he just refreshes his page and the session is available to him. Just in a diagram format, a user, a server, and an attacker in the picture, where initially the attacker sends the same social engineering tactics. He would send the fixed session ID, which he wants the victim to use. From there, the user will actually log into the server without knowing the session ID was already fixed. And that would be actually authenticated and authorized by the server, and user will have the session. And going forward, the victim can use the ready-made available session. That's it for this video. Thank you. Hello everyone, welcome back. In this particular slide, we'll be taking a look at the next attack vector for brute force. As the name suggests, the attacker is going to brute force the session ID value itself. In practice, we have seen scenarios where the session IDs are quite random. We are taking a look at a scenario where the session IDs are having a common pattern. Now, let's take a small example. Now, going back to this particular example, let's figure out what is the session ID that is being generated for this application. Now, as you see, the session value is 2020120001. So this is on the Chrome browser. Now, I've also initiated a new session on Firefox as well. Now, let's try to figure out what is the session value that is being generated. As you see, this value ends with the digit 6. In practice, an attacker can actually figure out a pattern that is being generated. For this particular demo, the pattern is in the format of YYYYMM, followed by a 3-digit increment value. So an attacker can always understand that if he can keep the first 6 digits as constant based on the particular day and the calendar year, that is, this is December of 2020. So in that way, he can ensure that the first 6 digits are being consistent and the last 3 values could be incremented since server is generating session IDs in sequence with an increment of 1. That could be an assumption. But however, the first 6 digits are being consistent. So based on this pattern, there are different ways of actually creating a brute force. The first and common method would be to actually send manual requests to the server with the session ID, expecting the value to be correct so that the session can be granted to the attacker itself. In order to automate, there are multiple ways to do so. One of the common ways the attackers do is to write some scripts. In this demo, we'll actually take a look at one of the tools. For example, brute force can be done by using a tool called Burp Suite. And there are community editions that are available for free for anyone to download. So now just let's take a look at that. As you can see, this is the Burp Suite window. So what is Burp Suite? Burp Suite is a HTTP proxy tool. So that means any request flowing through the browser would be captured in this tool first so that we can understand the parameters that are being sent to any specific endpoint. And based on that, during testing, we can tamper different values and send it to the server and figure out how the response is going to look like. We will not deep dive into how Burp Suite works, but this is something we'll be using in this particular tool. So what I've done is that I've configured the Burp Suite tool to work with Firefox. So you need to actually set up the proxy on the Firefox so that all the traffic is being rerouted to Burp Suite tool. So the default values would be the local host itself, that is 127.0.0.1, and the default port on which Burp Suite runs is 8080. So we are just going to use some basic settings. So the moment I sent a request to the web server, the particular request has been captured in this particular screen. Now, the request has not been sent to the server yet. So as an attacker, what we can do is that we can use multiple options. So one of the particular module that we'll be looking at is the intruder on this particular tool. So what I'm going to do is that click on action and send it to intruder. So intruder is module which can generate multiple payloads. It could be custom or generated by the tool itself. And those data can be sent at bulk to the server. Now, using intruder, we'll be taking a look at the parameters that are being sent. So as you can see, the tool has automatically detected a numeric value and it has been highlighted. So what we'll be doing is that we'll just change this payload. So there are multiple types of payload. We'll be using a simple one called numbers. Now we just need to type in the values that need to be generated. As we know, the format is YYYYMM. And the first value being 001. Now let's take a scenario where I want to generate a sequence till 8. Since we understand it is being generated in sequence maybe, we can just start the attack. And what's going to happen with that is it is going to brute force for each session ID starting from the value 001 till 008 with a step of 1. So just if we simulate the attack, we see that each session ID has been generated and sent in sequence. So this is one sort of example for brute force. There are multiple ways and multiple scenarios where the attacker can use different tools and scripts to achieve the same result. Now going back and understanding the attack on paper, let's try to reiterate the scenario. We have a user and a web server which the user is trying to access. And at the same time, we also have an attacker in picture. As you can see, the first request is when the user sends the request to the web server in order to generate a session ID. That is the same thing which the attacker is going to do so in order to understand if there is a pattern on the session ID. Then by doing so, he is going to send multiple requests by brute forcing the sequence ID of the session and expecting that some of the values may actually be valid on the server side. In that way, he will be getting access to the account. That's it for this video. Thank you. Hello everyone, welcome back. Let's take a look at the next attack vector called as session donation. Unlike previous attack scenarios where the attacker was trying to hijack the session itself, this is more of a phishing based attack. This attack is something to be aware of because in this attack, the main purpose is to gain access to sensitive information from the victim. As the name suggests, the keyword donation is quite significant over here because the attacker is trying to donate an existing profile such that the victim believes it's own and is going to fill out some information. Now just let's take an example. Taking a scenario where an attacker has created a fake profile for Tom, and Tom is being the victim over here. So what he has done is that he has registered an account on behalf of Tom, and as you can see on the home page, there's a user profile which is asking for sensitive information such as credit card. So the main intent for the attacker is to create each account based on the victim such that the victim believes that it is his own account and he is willing to send out some sensitive information. Now based on the attack scenarios, as we have seen in the previous slides, there could be a combination of attacks that could be used to gain access as well. Maybe there is a website which is actually vulnerable to cross-site scripting. So the user will actually create a profile and expecting the user to access it through phishing mechanisms and hoping that he can perform additional attacks in order to gain access to the account through phishing, or exploiting cross-site scripting, or any such scenarios what you have looked. But just focusing on the main intent of this attack, it is to ensure that this account has been created by the attacker and not by the victim, and making sure that the victim actually believes it is his own account. So in a scenario where the attacker was able to fool the victim in order so that he can click on the link and believing it is his own account and expecting the user to update the profile. So this could be such a scenario where the attacker reaches out to a victim saying that, hey, looks like your profile is incomplete. Please update your profile in order to access some deals. So it could be one such scenario. But the main expectation is to ensure that the victim accesses the account either by a loophole on the website such that just by clicking on the URL, a session is generated and the user is already logged in. So since this profile was created by the attacker and is donating it to the victim, hence the name session donation. Just to reiterate, the attacker is actually creating a fake profile on the website such that the user is actually being social engineered in order to access that particular profile. And by accessing that, the user might want to believe that it is his own account and he is wanting to fill out those sensitive informations. And once the user fills out the profile or adds any sensitive information, then it is up to the user to just access the same account since he was the owner in real sense. Now he can access that account and gain access to any sensitive information based on whatever the website is intended to do so. That is it for this video. Thank you. Hello everyone, welcome back. Let's take a look at the last attack known as Man the Browser. As the name suggests, the attacker is trying to compromise the browser the user is using. Since this is a client-side attack, the adversary will try to exploit vulnerabilities that may be present on the version or any other script that can execute to gain full or partial access. By doing so, the attacker is trying to gain control of the sensitive information that is being saved in the browser or can be used for any phishing scenarios. Now let's take a look at the common attack vectors as to how Man the Browser can perform. The most common scenario would be creating browser extensions. Most common major industry browsers such as Chrome, Firefox, they have multiple extensions available. So the attacker can create malicious extensions and distribute it to the users and expect them to install it. Once extensions are installed, they would need some privileges from the browser side in order to gain control. The second vector would be API hooking. All browsers would be using OS-based APIs in order to interact with HTTP protocol and to render the content and display it to the victim. So there could be scenarios where the attacker is able to create malicious APIs that are hooked onto the browser process and gain access. And one of the most easiest and common way is to execute malicious content on the web page itself, so that using social engineering scenarios, the attacker distributes the link, and once the website is run on the client side of the victim, the attacker will gain access. Now let's jump on to the demo. For this particular demo, we'll be using a tool called Beef, which is also known as Browser Exploitation Framework. This is something that is available in Kali environment. In case if it doesn't come pre-installed, it can be downloaded from the Kali repository. So the first step would be to initiate the framework. So once this particular framework is initiated, the two common URLs that we're interested would be the hook.js and second would be the UI panel. So hook.js is the malicious script that has to be injected on the vulnerable or malicious website. And that particular website is what would be distributed to the victims. And once they visit the website, the particular browser would be compromised. So in order to do so, I've already injected this particular hook.js in the demo website. Now the second step would be visiting the UI panel. So this is the default login page for the Beef framework. So let's log in with the credentials. So this is the administration page that hacker would be using in order to monitor the different victims. There are two different lists that are available. The offline browsers would be the list of victims. Those have already been compromised and not currently online. And the second list which we are actually interested in is the online browsers. So this is the list of victims who are actually online visiting this vulnerable page. So let's just click on this. Once we click on this, we see a list of browser extensions and capabilities that the script has fetched from the endpoint. So one of the tab that we're interested in is known as the commands tab. Just like any other major framework such as Metasploit, this Beef framework also comes with a ton of inbuilt malicious scripts. And those have been categorized under different scenarios. So these particular modules can be used based on the different type of payloads that we want to execute. It could be based on the vulnerability of the browser or any other host-based exploits as well. For simplicity, let's take a simple example of social engineering. I'll go ahead and just click on Google phishing. So this particular payload will actually push a fake Google login screen. And once the browser executes that, the victim will go ahead and fill in the username credentials, expecting it to be a genuine login page. And that particular content would actually be stored in the Beef framework. So one of the parameters that we look at is the hook URI. So this would be the return URI or the URL that we want the browser to send back once the victim sends the credentials. So I'll just go ahead and give a demo website. And once I click on execute, we can see that this particular page automatically refreshed and gave a fake Google phishing page. So in a typical social engineering, we expect the victims to type in their credentials. Once I click on sign in, this particular page would redirect. So let's go ahead and look at the logs. So as we see, we are able to see what are the characters that the user typed based on the inbuilt keylogger. So the username is being test and the password is test@123. So this is a simple scenario where a phishing exercise can be used and the browser can be compromised. Now just to reiterate the scenario where the attacker is trying to send the malicious URL that has already been compromised using Beef or any other malicious script. And obviously, based on the compromise or the access, the attacker can gain full or partial access to the browser. And hoping a scenario where the user again goes ahead and sends out any sensitive content on the malicious website, the user can access it. That's it for this video. Thank you. Hello everyone, welcome back to the next section. In this particular section, we'll be talking all about the different attack vectors over the network. What are the different tools that can be used in order to session hijack different protocols? To get started, we'll talk about the first attack vector known as TCP predicting the sequence. This is an old risk and not that something that we see on modern day. As we saw in our previous section, where we did take a look at the three-way handshake for a TCP connection. And in Wireshark, we did see that by default, the tool shows us the first sequence number to be a 0, but that is only for human readability. And when we looked at the actual data itself, it was quite sure that there was a pseudo random number that was generated and which was very difficult to predict itself. So what can generally happen during this attack is such that if an attacker is able to guess a particular sequence number that is being generated during the handshake, those packets could be forged. And while doing so, based on the type of attack, the attacker can actually inject the data or can actually send out different TCP flags in order to either terminate the connection as well. And these sort of vulnerabilities are actually seen in older OSs such as BSD Unix and Windows NT 3.5 and 4 as well. And this is something we don't see on modern day-to-day operating systems because they have ensured that every operating system can actually generate a random number such that an attacker cannot predict. Now, just let's understand the scenario. So, in a typical scenario where we have a user actually trying to create a TCP three-way handshake. So, as we know, the first packet that would be sent is the SYN flag. Followed by that, the server is going to respond back with the SYN and ACK. And in order to complete the three-way, the client is again going to send back the acknowledgement flag in order to complete a connection. So if we take the scenario where an attacker is able to send the flag such that he can predict the sequence in such a way, spoofing the source as the victim itself. So the server is going to respond back to the source, that is the victim over here, along with the particular acknowledgement flag in response. And in order to complete the third acknowledgement flag, the attacker is again going to predict the sequence and complete the three-way handshake. So this is something good to know basis as to how this attack has already happened. That's it for this video. Thank you. Hello everyone, welcome back. Now let's take a look at UDP session hijacking. We have previously looked at the difference between UDP and TCP protocol. So unlike TCP, there is no correct connection orientation in such a way that we don't track back as to if the request has been delivered. So there is no need for any sequence number in this particular protocol. So what really makes UDP vulnerable is that since there is no sequence of handshaking, so the protocol itself will not use multiple ACK key acknowledgement numbers so that the attacker doesn't need to forge them, all of these. Now in this particular demo, we're taking a look at a very basic example of UDP connection and how to hijack them. So let's assume that now, as we see, the connection was established. So we see that the connection was established and we were able to send the messages. Now, the tool that we're going to use currently is known as Scapy for Python. So this is a Python-based package generator that we'll be using. So once this particular library is enabled, let's go ahead and create a normal IP packet. Now let's go ahead and create an IP packet. And followed by that, we're going to provide the destination IP. So now going forward, we're also going to add the source port and the source IP as well. So let's create the additional UDP protocol details. We also need to specify the source that we are trying to forge. In this case, it will be the victim port that's being opened. So if we go back, we see that particular port 63868 is a port that is being used by the victim. So we need to add that as a source port. So let's create a payload. Now we need to compile the packet that would contain all the information of the IP along with the UDP details and the payload. Now just look at the packet that we have constructed. So as we can look at this, what we are trying to achieve by creating the entire packet was that we are trying to spoof as the victim who's connected to the server. So hence the source IP would be the victim's IP and the destination would be the server. And we have also specified the server's port that is opened and the current connection that is being established from the victim. And the payload that we are going to send is your hat. Now let's go ahead and send the packet. As we can see, the packet was sent and we can see we have spoofed a packet saying that from the victim's open port and the IP we are able to send by hijacking the session over here. Just to reenact the scenario, unlike TCP, the UDP protocol is not going to wait for a handshake. So once a client sends a request to the server, now the server is going to bombard back with the responses. So in this particular case, we can forge either the victim or the server by using this particular knowledge. That's the first video. Thank you. Hello everyone, welcome back. Now let's take a look at the next attack known as IP spoofing. As the name suggests, it is quite clear that the attacker is trying to spoof his own IP. This particular attack takes advantage of source-routed packets. So technically, an attacker is trying to hide the source from where the packet is being generated. So one of the primary purpose of doing so is that the attacker doesn't need to be in between the communication anymore, as compared to other sessions hijacking attacks. So one of the reasons this attack is used is to hide the source IP. In that way, an attacker, when performing a heavy load attack, doesn't need to use his own IP, but he can always disguise from where the packet is being generated. This common attack is also seen in DOS and DDoS just because of the purpose of hiding the IP. So or the person who's trying to protect the asset, he would not be able to confirm what's actual source IP, and an attacker can generate multiple source IP addresses. In that way, it is very difficult for an organization to protect against such attacks. And one of the other purposes is that if an attacker wants to send out any malicious content, he can do so by hiding the IP again. So now just let's take an example. So as you can see, I'm using my Kali box in order to perform a simple IP spoofing attack. So just for us to confirm if the packets are being spoofed, I'm going to use Wireshark. So I'm just going to record one of the interfaces, that is my local LAN. So the packets are being captured now. So what I'm going to do is that using one of the tool known as hping3. So this is the syntax that I'm going to type. What I'm trying to tell is that using this command is using hping3, I'm trying to send SYN packets for the target address, that is 10.0.0.96. As you can see the syntax, I'm going to use hping3 as a tool, and the parameters that I'm going to pass is -s switch for SYN attack, and followed by the target IP address, that is 10.0.0.96. And using the -a switch, I'm going to let know what is the spoofed IP address that I'm going to use. I'm going to use 1.1.1.1 as a source IP that is going to be spoofed, and -c switch is going to be used to let us know the number of packets that we're going to send. As you can see, we have sent 3 spoofed IP packets. Now let's go back to Wireshark and confirm that. Using the IP.address parameter, I'm going to search for 1.1.1.1. As you can see, we have 3 SYN packets that are being sent based on the command that we had used. So hyphen is used for SYN packets. That's what we see in each one of those requests. And the spoof address is 1.1.1.1. That is what we see as a source IP packet. Just to reiterate the scenario, initially the attacker doesn't need to be in between the communication channel, unlike other session hijacking scenarios. So the attacker is going to spoof the IP address of the victim. By doing so, the specific network device is going to respond back to the victim, because during the TCP handshake, using the source header packets, that is how a machine is going to know for which service it has to respond back with the communication. So just a typical data scenario, the attacker can keep on injecting different packets specifying a specific source IP, and for that, each one of those requests, the server is going to respond back. That is for this video. Thank you. Hello everyone, welcome back. So let's take a look at the next attack known as Talent Session Hijacking. As seen previously, Talent protocol is used to have a bidirectional communication between the systems. Since this particular protocol does not check the source IP address from where the packets are received, it is quite easy for an attacker to hijack any session, since the protocol will not validate it. Let's take a simple example. So this is the attacker machine in which the Talent server is running. So in this particular scenario, I'm just monitoring my own local network adapter, that is ETH0. So now we have started snipping the traffic. Now let's go ahead from the victim machine and try to log into the server. So the syntax would be telnet followed by the server IP address. So as we see a login prompt, and I've logged into this particular machine. So I'm just going to do some basic telnet activities such as listing the files and seeing the current working directory. So now let's go back to the attacker server where we are monitoring the traffic. We see there's a constant network sniffing happening. So let's go ahead and search only for telnet. So we saw there was a connection that was initiated and established. So let's look at the ports that are being used. So we see that the server is running on the default port as 23 and the client is connecting on 1371. So now we're going to use one of the tool known as Shyjack. So using this tool, we can intercept on this particular port for telnet. So I'm going to run the Linux executable for Shyjack. Then we are going to connect to the particular Ethernet adapter. That would be my local Ethernet adapter, in which I'm going to type in the client IP that was connecting, followed by the port that was being used by the client. So that would be 13C1. And the server and the port that's being running. So let's try to generate some more normal activities. So we saw that a particular hijack was able to intercept the sequence packet for the initiation and it was able to hijack it. What I'm going to do is that create a folder I'm just using the command mkdir and the folder name. And now the victim, since his connection was lost because we had intercepted the particular session. So now let's go ahead and log in again. And let me just list down the folders. So now we are able to see that a folder was created, name you are hacked. This is what the attacker sent using this particular hijack tool. So this is one such scenario where an attacker is actually routing all the traffic towards him. And in that scenario, we know all the information such as the client and the server, the IP addresses, and the port numbers that is required to hijack the session. Just to reiterate the scenario, assuming a scenario where a victim is trying to access the server and we have an attacker who's actually half spoofing it in such a way that all the traffic is routed towards him only. Using this, he can sniff the required basic details such as IP addresses and the port numbers. And once the victim's option is already connected, you'll be performing some basic activities to generate more traffic. Using that, we will be able to predict the sequence. In that way, an attacker would be able to perform any malicious activity that's required. That's it for this video. Thank you. Hello everyone, welcome back. Let's take a look at DNS hijacking. So DNS protocol is actually used to resolve the IP address and the host names. In this particular attack scenario, the attacker main intent is to update the DNS entries on the servers in such a way it always gets resolved to malicious website or phishing scenarios. Hence, these are commonly found under phishing and farming attacks. The attacker is planning to compromise either the local DNS entries on the machine or the router itself in such a way that the entries are updated to fake DNS. The next common attack vector is the man in the middle, and the last being setting up rogue DNS servers. Now let's take a simple example. In order to do so, what I'm going to do is that we'll open up the host file that is available on your Windows System32 drivers and etc folder. The same file is also available on Linux under /etc folder. Once we open this file, we see that there are no entries made. So in order to do so, we just need to enter the IP. So this is the IP address where the phishing website will be hosted. followed by what is the name that we are planning to resolve. So in my scenario, let's create a fake entry. And we'll just save this file. So just taking a scenario of standard phishing where an attacker sends out messages to all the victims saying that, hey, there is a new movie available on Netflix, and he just gives out this link. So as a victim, once he accesses the particular website, we see a fake login page. So this is one such scenario that can be achieved. To reiterate the scenario where we have a victim who's actually trying to access a URL, and the attacker is updating the DNS entries in such a way that the actual legitimate website is not available, but the attacker's own fake website is the one which the victim visits, and based on the scenario, he can gather sensitive information. That's it for this video. Thank you. Hello everyone, welcome back. Now let's take a look at the ARP spoofing attack. ARP stands for Address Resolution Protocol. Now this is a protocol that all the machines use in order to resolve the IP address and the MAC address. So MAC address is typically the unique address that all the network adapters carry with them. So over a local area network connection, initially, whenever we try to connect between computers, the particular host is going to check in the local ARP table. So that ARP table, if it has got an entry, then it is going to send the data to that specific IP address and the machine. So in order to do that, the ARP protocol itself is going to broadcast throughout the network seeking the information as to which machine owns that particular hardware address. So now let's talk about the attack itself. So the attacker is quite interested in performing this attack is because this is mainly used in man-in-the-middle attack over a local area network. And by doing so, what the attacker is trying to achieve is that all the traffic is routed through them. So in order to do that, all the victims' machines will actually be bombarded with data to update their ARP table. In such a way, based on the ARP table, all the data is again going to be routed through the attacker. So the common reasons why ARP spoofing attack is used is to create DOS service. For example, when an attacker wants to bombard a particular machine, then he can update the ARP table for all the other machines. So by doing so, all the machines would be confused and rerouting all the traffic to one particular machine, resulting in denial of service attacks. And the other common attacks are performing man-in-the-middle scenario in either to sniff the data or to hijack an existing session for a particular protocol. Now, let's go ahead and look at the demo. So let's try to see what are the available network adapters on a local machine. So by using the if config command, we can understand what are the available network adapters. So here we only have one adapter that is ETH0 connected, and the other is a loopback adapter. Now, in order to figure out the exact hardware address that is assigned to our local ETH0, let's go and type the command ip-link. So by doing so, we see the particular Ethernet hardware address that is assigned, that is in form of X. Now let's take a look at the local ARP table by using the ARP command. So this particular machine has communicated to all of these machines over the network, and it has a table which has an existing hardware address. So whenever this particular machine is going to communicate, it is going to send to the specific hardware address that is assigned to this IP address. Now let's try and perform man-in-the-middle attack for ARP spoofing. So for this particular scenario, we'll be taking a look at one of the tool known as EtherCap. This is something that is available inbuilt with Kali Toolkit. So the first step would be that by default, this tool will actually start the network sniffing. So before that, let's go ahead and see what are the hosts that are available over our network. By going to hosts and scanning for hosts, we'll get the list. So again, going back to host list, we see a huge table letting us know what are the different network devices or servers connected to a particular network with a particular MAC address. Now, for this particular attack, we are taking one target to be the gateway. In my scenario, it is 10.0.0.1. So this is the router or the gateway that I'm going to add as a target. A second target would be a specific machine for whom we are trying to perform man-in-the-middle attack. So in my case, it is the 96 machine, that is a Windows machine that is available over the network. I'm going to add this as a second target. And after doing that, we are going to start the ARP poisoning. So when we start the ARP poisoning, we see two options. One is to sniff the remote connections. That is something that we want in order to gather sensitive data. And second is to specify if it is a one-way poisoning. That means we just want to broadcast and not them to send back the data to us. So since we want all the traffic to go through us, we will uncheck this second option. So as we see, the ARP poisoning attack has started. So now let's take a normal scenario on the victim side. So this is the victim who is trying to access a page and where there's a login page, and the victim might fill out any sensitive information such as username, passwords. So after the user submits the page, we see that this particular tool was automatically able to capture the username and the password for a particular website that the victim was accessing. So this is once a scenario how a man attack can be performed using ARP poisoning, such that all the traffic is sent through the attacker machine. Just to reiterate the scenario, we have an attacker, user, and a server. So initially, the user might send a request to the server, and the attacker is trying to spoof the hardware address in such a way, in both the cases, that now the victim and the router or the gateway believe that they need to communicate through the attacker only. So in such scenario, a typical man in the middle attack can happen. That's it for this video. Thank you. Hello everyone, welcome back. I want to talk about one of the last attack under this category known as SSL strip. As the name suggests, the attacker is going to strip out SSL connection using man-in-the-middle attack. Now, what the reason attacker is trying to do is because whenever we use SSL protocol over any of the existing such as FTP or HTTP, it will actually encrypt the traffic. And using that, the attacker will not be able to hijack the sensitive information or any other data that is willing to understand. So the attacker is going to ensure that if he is able to downgrade the SSL protocol itself, then he can downgrade it to HTTP, and using that he'll be able to sniff the traffic. Now, one of the primary ways would be to use ARP spoofing. This is because we need to ensure that all the traffic is being routed to the attacker machine only. Next, using proxy server. Once we use a proxy server, all the traffic would be rerouted to the same proxy server, and we can terminate the SSL on that instance as well and read the data in plain text. And one of the last would be to have open Wi-Fi hotspots where the user connects and is not aware that the traffic is being routed and everything is being sent in plain text. Now, one of the tools that I'm going to show today is known as BetterCap. We are going to assign one of the interfaces where we are going to strip the traffic. In this scenario, it would be ETL0. Now, let's look at the basic commands.
These are the multiple modules that we need to enable before sniffing the traffic. So let's start with setting up the SSL strip. So the next would be to enable the network capture as well. Now also let's perform some ARP spoofing. Now as we see, all the traffic is being currently sniffed using this tool. So one of the demerit of using this attack into this scenario is because not every browser would be vulnerable to downgrade it, and at the same time, if the users are using any cached URLs, so that would not be downgraded. And at the same time, if there are strong HSTS signatures set up, that will enforce the browser only to redirect to any SSL encrypted traffic only, and it will check the domain as well. So this particular attack will not be foolproof given the multiple complications on the browser. So the ideal scenario would be when the user is trying to access an HTTPS URL, the attacker is going to spoof all the traffic towards himself such that he is able to strip out the SSL on his local machine, and the same data is forwarded to the router and again back to the server. So in that way, the communication is maintained through the attacker himself, and SSL strip would ensure that the connection is terminated while he reads the data in plain text. That's it for this video. Thank you.
Hello everyone, welcome back to the last section of this course. As we have seen various attack scenarios in both web and network as to how an attacker can hijack sessions, now let's try to understand how do we secure them. I want to start out by saying that session IDs should be treated as passwords. The reason being that the way we treat complexity of the password to ensure that they are not following any dictionary patterns or it is not something that is guessable by any attacker. That way, we have to ensure that the session IDs that are generated are quite random. So if you remember a particular example that we looked in the hands-on section where our session IDs add a typical pattern in the form of dates. So given a certain amount of time, an attacker can actually reduce what is the pattern in a small window. By doing so, what's going to happen now is that the attacker can generate new session IDs. Now, based on the vulnerability that our website might possess, maybe a session fixation attack or a brute force attack. Any of those scenarios can actually give an attacker a certain amount of time to actually send those new IDs to the server and to check if those sessions are actually valid or not. There should be no reason for the developers to generate the session ID themselves or to create a pattern of their own. All of the common frameworks that exist in the market, maybe .NET, PHP, or any such primary languages, those frameworks do handle session IDs quite well. By that, I do mean saying that they do generate a random session ID. Unlike the vulnerable website that we saw in the demo, where it was only numbers and along with the pattern, these frameworks will actually help generate a random number using both alphabets and numbers. At the same time, they also give an high entropy in terms of the size. By doing so, what's going to happen now is that those random generated long strings are quite hard to brute force. Reason being, just to remember this important fact that session ID is actually valuable till the time it's valid. In order to brute force a large string with all of these possibilities is going to take quite a long time, and by that time we should have additional measures to expire the session. And even though a user session ID is actually being guessed after a certain amount of time, but the attacker can no longer use it. Another sort of attack that we actually looked was where the session ID was being passed in the URL. Now, what is going to happen in those scenarios? We really don't want any attacker sitting in an open cafe to sniff our URL. Or there are scenarios where end users actually share any existing URL to their friends or colleagues over social media. Unknowingly, the session ID being present in the URL now becomes a very big threat because we don't know if an attacker is actually awaiting for all of these social media guys post any such URLs. Second problem would be, since all these websites communicate within each other, so these session IDs sent as part of the referrer header also get logged at multiple destinations. The way our web server will also behave is that any user accessing the URL gets logged into the access log. So given a scenario where the server itself is compromised and all the URLs are being logged in the access logs, the attacker now no longer needs to wait for a vulnerable website or any social engineering tactics. He can just go ahead and access the log and get fresh, new, available session IDs. So one of the common scenarios that you have seen is because the developers, they use HTTP GET method. The problem with that method is that all the parameters will always be sent as part of the URL. So one simple way to mitigate them would always be to use post method. Post method ensure that the request is being sent as part of the body. And a much better approach would always be to use cookies. So as we saw in our initial videos, cookie is a file which actually gets stored on the browser. Now there is no need for any vulnerability to be present in the URL. One of our common big attack vector that we saw was session fixation, where a particular session ID was generated and being given to the victim, and that particular session ID was fixed as part of the vulnerability. So there lies the actual issue where the server was not actually regenerating the session ID. If the developer was smart enough to ensure that once a person is trying to re-authenticate or a session ID is actually expired, then we ensure that a new random session ID is generated. So that itself will actually fix a lot of session fixation attacks. That's it for this video. Thank you. Hello everyone, welcome back. Now let's take a look at the second way of persisting the session using cookies and how do we secure them. If you go back to our first hands-on under the web section, where we were able to hijack the session using reflected cross-site scripting attack vector. One of the reasons the attack was really successful is because of the scripts that are being run on the browser capable enough to access these cookies. In practice, even though these are saved in the browser, it is a server who really needs them to authenticate the session for the user. There is no role of these scripts needing access to any of these cookies. One of the ways to secure them is by enabling this HTTP flag. HTTP only flag is going to instruct the browsers saying that none of the scripts should have access to these cookies. One of the other parameter that we are looking at is a secure flag. As we have already discussed, that the session ID should be treated as passwords. That means these are highly sensitive. Any sensitive information should never be sent in plain traffic. That means it should always be sent using secure protocols only. So by enabling this particular flag, we are instructing the browser to only send these cookies whenever the connection between the browser and the server is done using HTTPS protocol. By doing so, we are avoiding multiple man-in-the-middle attack and the scenarios one really accesses the browsers on open Wi-Fi networks such as Café. One of the important factors for any cookie is that how do we expire them? This is one particular topic I would like to touch base on. Taking a scenario, especially in social media websites, where we persist the session for a longer point of time. That is because none of the users accessing the social media multiple times in a day would want to enter the credentials every time to access those. So those are those business requirements. But now it is about keeping the balance between the business use case and security in place. If we have a session expiring for a longer duration of time, we do give a large amount of window for the attacker to gain access to the sessions. There could be multiple attack vectors that we looked at. For example, performing brute force or performing various other attack scenarios and gaining access. At the same time, if we implement a very short window of expiring the sessions, that becomes a trouble for the user to always re-authenticate and persist the session. Either ways, this is something we need to take into consideration, and we can use this flag to put out a certain window as to how much should the session be valid, and that is something we always need to enable. And one of the last parameter that I would like to talk about is the same site and domain parameter. So by setting these values, we are instructing saying that which particular domains should the cookie be passed. In today's scenario, all the websites are quite complex where there is a use case of multiple websites accessing the cookies between each other. As long as there's a valid business case, you can always pass those cookies, and that is where this particular parameter is going to enable security, where we define the domains as to whom should the cookie be passed to, and so that they can consume and authenticate the user. That's it for this video. Thank you. Hello everyone, welcome back. Now let's take a look at how do you secure the network session hijacking attacks. One of the basic things that I would really like to touch upon is the network being open in such a way that the communication is always being sent in plain text. As we have looked at the various attack vectors, in most of the cases, attackers sitting on the same network was able to sniff the data since it was being sent in plain text format and either read a sensitive information or he was able to read the packets that are being sent and perform various applicable session hijacking techniques. So in order to prevent all of this man-in-the-middle attack, we should ensure that we implement TLS in place. So what do I mean by that is that, to name a few protocols, starting with HTTP, that is being used by all of our web servers by default. So if we implement HTTP as a protocol, that is going to ensure that all the data is being sent in plain text. We need to ensure that we add an additional capability of SSL layer. That means we need to generate SSL certificates that are added on top of this protocol in such a way that the data is being sent on HTTP protocol only, so that even though attacker tries to sniff the data, it will always be encrypted in nature. One of the protocol that is commonly used in the industry is FTP. This is used for file transfer mechanisms. So even this particular protocol possesses the same thread. By default, FTP will always send data in plain text. In order to prevent this, either we have an alternative of adding SSL layer so that we initiate FTPS connection so that data is always encrypted. One of the alternative could be using SFTP. So SFTP would be running on top of SSH and ensuring the data is always encrypted. All of our companies use email exchange protocols such as IMAP and POP and even SMTP. All of these particular protocols can also be implemented using TLS and SSL so that all of the sensitive communication always happen through an encrypted channel. So now let's take a look at different secure protocols. For example, when we talk about Telnet itself, which we actually saw, which actually opens up a bidirectional connection. The Telnet also has the same vulnerability, but instead of using Telnet as a protocol itself, we can actually switch to SSH as a protocol. SSH will also provide the same mechanism in order to log in, and this will actually create an encrypted tunnel, ensuring the data is always encrypted and is always between the two endpoints. In cases where SSH can directly not be used, and if we want to connect to a critical infrastructure, we can use VPN. So these would be the virtual private networks that always run, establishing a secret tunnel between the endpoint and the network. So anyone trying to snip the traffic between the endpoint and the particular infrastructure network, it will always be encrypted. So these two protocols can always suffice the need wherever we need to have secure protocols implemented to encrypt the traffic. That's it for this video. Thank you. Hello everyone, welcome back. We have touched base as to how do we secure session persistence across web and basics of network security. Now let's take a look at additional best practices that can be incorporated in order to strengthen the security posture. First thing that I would like to talk about is segregating the authentication and authorization in the application. Typically, the way an application behaves is that once a user logs in, we generate a session ID that is being passed throughout the application for all the actions. The approach would be to create a new auth token that is generated using all the security requirements, the way we generate a session ID, and that particular token is used for all sensitive actions. For example, maybe updating a profile password or maybe transferring money. Depending on the application requirement, if we can segregate the sensitive actions performed by the user and we use the auth token to actually authorize and see if that is being generated in a timely fashion and meeting all the access requirements. That way, we can add an additional layer of security. We have seen attacks such as brute force or session fixation, which lack session management. The reason being is that the way the session management was implemented is from the developer point of view. They themselves took the ownership of creating the session, maintaining the session, and purging the session. It would be a smart way to develop an application using their own inbuilt session management. For example, all the big frameworks such as Java, PHP, and .NET technologies, they have their own built-in session management. In that way, we don't need to worry about how do we create a session ID if it is secure enough or not. All these technologies do follow industry standards. For example, they do generate a long string for a session ID that are quite random in nature. At the same time, they also ensure how the data is being transmitted and adhering to all the session management principles. The next thing that I want to talk about is the used versus accepted mechanism. For example, if we do understand that a session ID has to be passed to the application which is consumed by the server is through a certain way, for example, either through the cookie. So in that way, if an attacker is trying to inject the same session ID through other variations, such as through the URL or any other form factor, that should not be accepted. So as a developer, they need to ensure that how are they actually incorporating these sensitive information such as session ID in terms of consuming for authentication and authorization. One other thing which is quite important on all our application is that to ensure that we encourage the users to log out. The reason being is that as long as a session is active, that's where it creates a value. The example that we spoke about, where social media applications do require the session to be maintained for a longer period of time. In those scenarios, most of the users would actually just terminate the browser and actually just access the application the next time, and the session would be persisted. But in case if the users are encouraged to log out, it would not really matter because the session would be purged. We do need to take additional precaution that an additional layer of validation happens on the server side, stating that since the user performed the logout action, that particular session ID value no longer persists. So this is one other common security best practice that we should encourage the users to do so. One of the recent technologies is HTML5, and this particular technology actually store the information. So there are certain APIs that are capable enough from the HTML technology point of view, which actually store information in the local storage. And there could be either information leakage or other applications accessing the shared system. So we need to ensure that proper security mechanisms are implemented while using HTML5. The next thing would be to ensure that the session IDs are also treated as user input. What we mean by that is that unlike any user input that is being fed to the system, either through a form or through an API, we do ensure that all the common web attacks are terminated either for cross-site scripting or SQL injection or any other applicable attack. So similarly, we also need to ensure that even the session ID value also doesn't contain any invalid character that can break the application and maybe give away to a new vulnerability. So just to reiterate, we just need to sanitize all the values that are being consumed by the application, starting from the user input through the session IDs that can be tampered. One of the use cases we want to talk about is the complex web applications. For example, in an ecosystem, a person is trying to perform a single sign-on, and that particular user is also capable enough to access multiple applications under the same industry. So we need to be cognizant of the fact that while generating individual cookies for each application, how do we actually maintain the persistence for each one of those in terms of authorization and authentication? For example, the basics would be to ensure that both the cookies that are being used should have a different nomenclature, such that it doesn't happen where one of the application whose expiry time was in a standard industry format and the second application being a social media which had a long expiry date. But just because of the fact that both use the same cookie name and there were no additional cookie flags that was set in terms to validate who can access, then that becomes a new threat where that particular cookie value is applicable throughout the multiple web browser sessions. The next thing is something that we already spoke about, saying that if we can segregate the authorization and authentication of the application, we can add an additional layer of re-authentication for critical actions. This could happen in terms of a multi-factor, or it can happen where we actually ask the user to re-log in so that we can validate and provide a new session ID. So while generating session ID, we can also add additional factors such as the source IP or the user agent to bind in such a way that we can uniquely identify from where a person is logging from. In that way, if there is a requirement where we want to avoid multiple session IDs being generated, the other parameter can actually always help to differentiate between simultaneous access. That is all for this video. Thank you. Hello everyone. I would like to conclude this course by thanking you all for joining me on this exciting course. I hope everyone got to learn about some other new technique or some way to use the different tools. We saw various sort of possibilities that could occur based on a given scenario, and the attacker may choose to use any one of the tools or multiple tools based on the attack vector. So the examples that we looked at
are for more against weak infrastructures and by default configurations that may lead to such common exploits. However, there is no stopping an attacker to use chains of these attacks and maybe using any other vulnerability based on the different ethical hacking models that are available. For more additional information on cybersecurity, I would recommend people to learn in depth about Kali Linux so that all the tools are hands-on. And since all the technologies are currently moving onto cloud infrastructure, that would be a new way to learn additional security measures. And the way we have looked at, most of the common web attacks fall under the prey of improper secure coding. That is another strong technology that people can pursue in order to secure applications. And lastly, I would also recommend to start about threat modelings such as Stride and so on. Thank you all again.